I'm going to be showing how I would multiply impute data. I'm going to be showing this in an example that I already have here, which is of our cardiac interoception data, for which we are going to be using a signal detection paradigm approach. I will now be sharing my screen to show you how the data looks. So in the raw form, when the data is given out by the algorithm, we have here like a lot of variables and stuff, and this is just a text file. So the first thing that I would do is open SPSS and import my data. Import data, text data. Now I have to see, is it this one? Yes, that should be it. Open. Of course, with this will now take a while. Next. Okay. So this is our data file. Now, as you can see, we have some rows that are completely missing here. Then over here is some stuff that's missing. Yeah, so that's actually quite a lot. I will actually concentrate for first only on the rates, which is basically like what people pressed in the paradigm that they had, button presses. So actually, first of all, what I'm going to do is I'm going to sort this, although this is of course not necessary, and I'm going to put my ID at the very top. There, so that I know. Okay, and now you can already see better. Okay, in some conditions, BED stands for Bedingung conditions. There were more dropouts than in others. Conditions till 80, that's a mistake that the algorithm makes. We didn't have 80 trials. We only had 54 trials, which is 50 trials plus 4 test trials in the very beginning. And we can see there's quite some missing data. The first thing that I would suggest in this case is to see in how many cases basically everything is lost. Because we usually say that, okay, we need at least 25% of the data to still be there, or even more per case. I would suggest using like a heuristic like 50%. And so I'm going to try and figure out how many people that is, and you can already see a few. And in my case, I will delete these people out of the data set because I can't use them. But of course, like if you're going to do something else, just filter them out or something, that is up to you. So what I am going to do now, maybe also a bit unconventional, is I'm just going to check how many people actually had the 54th trial, and I'm going to sort ascending, and we can see that 8 people didn't have the 54th trial, but they also kind of drop out much earlier. Okay, so maybe with this person who had 44 trials, we can sort of keep them in. But with the rest, it's just so little data that I'm going to opt to just get rid of these people. So that was this person was okay. This person, have I got that right now? Oh, no. Okay, clear. Good. So now we still have some missing data in here at the top, for example, and there are a few places like in the variables where things are missing. So there is a point of imputing the data. Next thing that I'm going to do is I am going to tell SPSS that we have missing data and what I'm going to call the missing data. So I am going to open a syntax file. Sorry, a new syntax file. And this work. Okay. So now I told SPSS that in this rate data, these ones are missing. Okay. Next, I am going to start the, well, next we can, of course, first have a look at how many things are missing. You can look at missing value analyses. And for example, we can have a look at rates. I said 54 variables that we have, so there's, oops, 54 variables. So I'm just going to do this, and you can see that occasionally we do have some missings. It's not many, but you know, occasionally we have some missings. So that's how we know, okay, how many missing data items do we have? And this is what we're now going to impute. So I'm going to go back here. You go analyze, multiple imputation, impute missing data patterns. And I want at least 10 imputations because, as I said earlier, with less than 10, you can't really know whether everything is quite precise. I am going to insert everything into the model. I am going to create a new data set name, and I'm going to call it new imputed data. Sorry, I'm going to write this to a file and call it new imputed data. And then I'm going to have a look at the method, and I'm going to do a custom full conditional specifications. And as the maximum iterations, I'm going to do 100. Yeah, because like with iterations is meant that in the background there is an optimization process with which the, for example, the standard errors and things like that are calculated as precisely as possible. So if you give the computer more time, it will be more precise on that. But you, of course, also don't want to give the computer unlimited time because otherwise, yeah, that's a bit difficult because your computer will never be done and it will just be too much RAM used up. I do not want to do linear regression because I don't think that heartbeat data acts in a linear way. I think it is more conservative and maybe therefore better to say that we are going to do predictive mean matching. Yeah, 5 predictions sounds good to me. Now there are multiple variables in this model. Like, I mean, I basically put in everything, but for example, I don't think that ID is a good thing to use as a predictor. So I am going to say, yeah, if it's there, imputed, but we don't have missing ID variables. I don't want the ID to be used as a predictor. Okay, so what I would do now is I paste that. Now, I've already prepared a little bit of that data set, so I'm now going to share my screen again of how it went on. This is the syntax that I want. And what I said here is you can also like put in a minimum and a maximum value, and if you want things rounded. So I said, okay, even if the thing comes up with, like usually the algorithm shouldn't come up with any funny ideas, but because there was button presses in this rate thing, I wanted it to be between 1 and either 1 or 2 because those were the 2 options. And I didn't want any numbers in between because later the algorithm that I have to evaluate this data set does not allow for any comma numbers. So I said a rounding of 1. Min-max there. So that's also something that you can put in your data set. Yeah, it shows some things as indicators, maximum iterations. I think I had to put up some max model parameters before because sometimes it doesn't work like that. But then you can know, like you can make it higher with this number, predicted mean matching, yeah. So this is what the syntax will look like for you too if you're having a large data set like me. And then I will open this new file that I just asked as an out file, and this is what it looks like. So I have this first row, this first column, which actually tells me for the 10 imputations, which imputation are we in? And since I had a data set with, I think, 260 persons in it approximately, this is a very long data file. So we have imputation 0. And now what we want to do is view and mark imputed data. I already have this clicked here. Of course, in imputation 0, that's the original data, so you won't see any imputed data there because this is just the original data. But here, we are starting at imputation 1. You can see that the numbers have changed. And now we said only in the rates data that we wanted to see changes. And here you can see them. These are imputed values. And what's also a good check is that here we have the only 2s and 1s, so that means there are only full numbers, which is good for us. So now that I've imputed the data, I would now continue with the variables that I wanted to calculate from the beginning. The good thing is in this case that actually we have a special data, a special syntax of how to do that. So I will now once again share my screen to show you how this looks. One moment. Okay, so from the creator of this task, this cardiovascular signal detection task, we received this quite large syntax file, which has all the values that we need. I'm showing you this just to show you that, you know, with multiple interpretation, it also works with these huge data sets. As I said before, we have these imputation numbers, and that's one thing that we need to keep. So we are going to put in here imputation underscore, so that when we are using this bars to cases thing, which is basically transposing or pivoting the table the other way around, going from a wide data set to a long data set, we want to keep this imputation number because otherwise it wouldn't make sense to have imputed all this data. That's the one thing I have to change, and I have to change it here again because we have here, we're going back from the long data format to the wide data format. Yeah, as you can imagine, it takes quite a while to run all the syntax. So I've already run it for us. One moment. And here we are. Now, let's take a look. As you can see here, we have this huge data set again, and it's still got all the imputations in it. What I did though is now that I also have the D and the C rate, as well as correct answers, hit rates, false alarm rates. And yeah, so now what I'm going to do is I am going to go first again back into the data groups. I am going to split the file, compare groups, group based on imputation number, so that we can have a look how this imputation actually works and check so to speak in the background whether it's doing everything the way we want it. I'm just going to click OK here. That seems to have worked. And now I am just going to go analyze descriptive statistics. Okay, what do I want here? Just give me some descriptives for, yeah, let's say all these hit rates and false alarm rates, as well as D and C. And I'm going to click on done. And now what we can see here is that instead of a normal but quite short table and a descriptive statistics, we get descriptive statistics for every single one of the imputations. So here's the original data up to imputation number 10, plus the pooled variant. And now if you have a look at it, for example, the D-value. So the D-value is the sensitivity that a person has, of the hits versus, the targets versus the foils, the sensitivity towards that. And so in the original data set, it was around 0.696. And you can see that in every single one of the imputations, it is around that number. So there is a little bit of variance there between the data sets. But in the end, you get a slightly more, I would say slightly more reliable value, because in the pooled step, all these numbers are sort of pooled together. And instead of 0.69 around 6, so 597, you would have 0.6961. I mean, yeah, that doesn't make a large difference now, but remember that we had quite small missing data amounts. And so if you have more missing data, you would also have more problems with this, or like you would have larger differences between the individual imputation steps.